Hey Seattle Prep, this is just a short video to go over a couple of things from 1.5, and this is your homework, your guided notes homework. It's going to be pretty short because you also have algebra review, so we don't want to do too much. In class, we went over, and I'm just going to kind of scroll through the notes from my class, and you can check those out. And Miss Young's notes might be a little bit different. She might say things in a different way, but I'm gonna go through mine kind of slowly, and there might be something there that caught your eye. But we're gonna go straight to the stuff that we didn't get to because I want to make sure that we that you have a lot of time for the algebra review stuff. So angle addition postulate is one thing we're going to cover, and then how angles get bisected is the other thing we're going to cover. Now, if you remember, we already had the segment addition postulate, which said that if you had three collinear points that in this order B between, that AB plus A plus BC, little spacey there, plus BC is equal to AC. That you can take a big segment and break it down into smaller segments, and they all add up to make the big one, right? Well, you can guess that the angle addition postulate is about the same thing. So you can check it out right here, what the angle addition postulate means. It says that the measure of angle RST, so RST is this whole thing right there. The measure of RST is equal to the measure of RSP, that's the red one, plus the measure of PST, which is the green one. So what it means is that a big angle you can break down and make it the sum of its smaller parts. Just like with segment addition. So, it's just like if I have a big angle, I can think of it as a big angle. I can think of it as a bunch of little angles all adding up. And keep in mind, you might be wondering, well, what but there's that segment that's in the middle. But remember, that segment is like, or that ray in the middle, that ray is like infinitely small. So it's not taking up any space in the angle, and the two little angles add up to the big angle. And you don't have to worry about the fact that there's a ray going through the middle. So how do we use this thing? Well, in a very similar way to you saw with angle addition. So with segment addition. So here's the example here. Given that LKN equals 145. So I want to put that in the drawing. So what angle is that? So I'm reading the letters, LKN. Remember, the middle one is the vertex. So that's the vertex of this angle. So LKN. So that's the whole thing. So this whole angle, and I'm going to mark it on here. I got all that writing in the way, so I'm going to write it like this. The whole angle is 145 degrees. That's what it said over here. So it's saying that it takes 145 degrees to turn from facing L, if you're standing on K, facing L to facing N, right? And they're asking you to find the measure of these smaller angles, LKM, that's this little one right here, and MKN, that's this angle right here. And so it's a question of the two small angles adding up to the big one, but we don't know how big the small angles are because they've got x's in them. So just like segment addition, we'll set this up the same way. We'll say the two small ones, so 2k plus 10, that's this angle over here, plus 4x, I think I said k, but x, minus 3, that's this angle over here. That's equal to the whole angle, which is 145 degrees. Now I could solve it. Let's see, add like terms, 6x. I'll add the numbers at the same time, plus 7 equals 145. So I'm going to subtract over the 7. So 6x equals 138. What? But that's okay. And then I'm going to divide by 6. So x equals, so 6 into 130, that's going to go 20 times and leave me 1 left over, and 6 into 18 goes 3 times, so x is 23. Woohoo! Whoops, I was going to write a sideways happy face there. Happy face, yay! Moving on. Next one. Oh, did you spot it? I was trying to hide that there. That was not the answer to the question, because the question asked something different. Make sure you're answering the question that they actually ask. So it says, find the measure of LKM. So how big is this actual angle? Like, this is sorry about that. I'm in I'm in Adelphia, and the lights just went out in here, but okay, I can see. I think, I look a little weird, but you can see. Okay, so this is giving me a formula for figuring out how big the angle is, and now I know what x is, so I can work it out. So angle LKM is 2 times x, and now I know what x is, 23 plus 10, which is 46 plus 10, which is 56 degrees. Is it right? Well, I don't know. Let's find out what the other one is, and then we'll be able to tell. Angle MKN, that's this one down here, and it's 4 times 23 minus 3. 4 times 23 is 92 minus 3, which is 89. And if you add those two together, sure enough, you get 145. So yay, it worked. All right, now bisecting angles. So an angle bisector is a ray that divides an angle into two angles that are congruent. Kind of like we had a midpoint that can bisect a segment. Same thing here. You've got angle bisector that bisects an angle. So if you see an angle and you see a line coming through it, you don't know that that cuts it in half. Like, if it looks like it kind of cuts it in half, that's not good enough. Like, because maybe it's close to cutting it in half, or maybe my drawing's lousy because this is Mr. Ellinger and he doesn't draw that well, and so maybe that's the issue. There's all kinds of things to be going on, and you can't assume that these two angles here are exactly the same size. So if the only way you can do it is if they tell you. So the two ways they could tell you is they could tell you in the problem. They could say, like in the one we're about to see, it says BD bisects ABC. All right, I guess it's a bisector. So they could just tell you that it's a bisector, or like in the drawing, they could mark that the angles are congruent, and then you go, oh, okay, if those two angles are exactly the same size, then this ray here, AB that I'm making, this ray must bisect the big angle. So you need to have some reason for knowing stuff. You can't just assume it because it kind of looks like it. And it's the same idea, just to be clear, it's the same idea as with midpoints. If you see something in the middle, you say, is that a midpoint? You go, I don't know. But if I tell you these two are congruent, then you go, oh yeah, okay, yeah, then it's definitely a midpoint. Okay? So you have to have clear information from the drawing or from the problem. So here's an example of one where it does that. It says BD bisects ABC. So this is equal to this. Find the measure of all the angles. So it's ABD. It's the little top one, and then the little bottom one, and then the whole thing. Okay. So how do we do this? We set up an equation. But unlike the other one, in the other problem, they told us what the whole angle was equal to, and then we could add these together to make the big one. That was angle addition. In this one, they don't tell us what it adds up to. Now, you might look at it and think, it looks like it adds up to 90, Mr. Ellinger. Maybe not. Maybe that's just an optical illusion or something. So I can't assume that, and there's nothing saying it adds to 90, so I don't know what those two angles add up to. But I do know that they're exactly the same size, so I do know that 6x plus 14 has to be equal to 3x plus 29. So on this problem, I could set the angles equal to each other because they told me they were equal when they said that BD bisects the angle. Bisect mean cut in half on the nose, not cut in the middle somewhere. Bisects, divides into two exact parts. But in the first problem, I couldn't set those things equal to each other because they never said they were equal. They gave me the sum. Just trying to show you, because these are going to be the two most common ways we set up equations. We'll have two things we can set equal to each other, or we could say, well, these things combine to make something else. And you have to make sure you have the right kind of equation for the kind of problem and the kind of information they've given you. All right, we're going to do the last part fast because I want to try to finish this up. So now we can solve the equation. We'd subtract 3x, and so we get 3x on this side. The equals is staying there. And then I'm going to subtract 14 because I want to move the 14 over. Minus 14. So 29 minus 14 is 15. And x is equal to 5. X equal to 5, you could plug it in, and you'd get that angle ABD is 6 times 5, which is 30, plus 14, plus 14, which is 44. I said that horribly. And angle DBC is 3 times 5 plus 29, which is 15 plus 29, which is 44. And look, they didn't add up to 90. They added up to 88. And so the whole angle is 88 degrees. And so, yeah, it was close to 90, but it wasn't quite 90. All right, what have we gone over today? We've gone over what it means to add angles together to make a big one, angle addition postulate. And we've gone over when angles are bisected. And I try to make a big thing about not assuming things are bisected unless you have a reason to know that. And then once you know they're bisected, then you can set the two parts equal to each other, because knowing that it's a bisector means that they're equal. Okay? That is it. We'll look at the examples in class. You're gonna you should take these guided notes and make sure you got them, and that'll ready you for Tuesday. And then start working on algebra review, or not start. Continue working on algebra review stuff so that you can be ready for the mastery, our first algebra mastery test on Tuesday. Okay? Take care and have a wonderful weekend, and we'll see you then. Bye-bye.